Here we are seeing about the solar power generation with power smoothing function. That is, we are using one PV panel, one battery, and using those two sources, we are providing power to the inverter, and that inverter consists of a dual input. That is, a battery set and a PV source, and that switching over the sources will be smoothened with the controller. For PV panel, we have a separate boost converter, and for both PV and battery, we have a separate dual input buck boost inverter. So the inverter will also operate under the buck boost, and a separate boost converter for PV MPPT is used here. The simulation circuit can be seen here. In this, if you see, this is the PV plus boost converter, and that will be the output of the boost converter will be combined with the battery and the inverter part, that is buck boost inverter part. These are the control loops. In this, we are calculating the PV power from the voltage and current from the PV. This is voltage, this is current, sorry, power, and from that we are getting V reference and dP. That is, V reference will be generated from the MPPT, and dP is change in power with that V reference, how much power is changed. If it is in positive, that is greater than 5, that is considered as P1, and this is less than -5, that is considered as P2. So if it is positive or negative, according to that the control signal will be provided as 1 or -1. That control signal is added here, and this is V reference. V reference is compared with the measured PV voltage, and according to that the pulse will be generated for the boost converter. Here if you see, for the boost converter switch we are using that V reference and measured PV voltage. The error between those two will be provided for the pulse generation for the boost converter, and after that the difference is added with the control signal, and it is multiplied with the reference sinusoidal waveform. From that we will get a sinusoidal current, that is inverter current, and that inverter current is compared here, and error is given to PI controller. With filter and without filter, and with filter it is given to S1, without filter it is given to S2. S1 is directly the PV power is, when PV is available S1 will operate, when PV is not available S2 will operate, that is the battery, for the battery. And same reference is taken and provided for the inverter pulses, a single phase inverter, so two pulses are required, for positive cycle one pulse, for negative cycle one pulse, and the inverter is connected to AC load and grids. In this, if you see, means grid voltage and inverter voltage we will get it. Okay, initially when PV is available, the inverter voltage is around 400 volt, and when PV is not available, the inverter voltage is around 300 volt. That is the second waveform. First waveform is grid voltage. It is around 230 or 240 volt. And this is PV parameters. That is PV voltage, PV current, and PV power. PV voltage is around 220 volt. PV current is around 38 amps, and PV power is around 8 kilowatt. And here these are battery parameters, battery voltage and SOC. Initially the battery was charging when PV is available, and when PV is disconnected, then the battery starts to discharge. So the SOC is initially increasing when battery is charging, that is when PV is available. And when PV is not available, battery should provide the energy. So the battery state of charge is decreasing here. And this is load power. Initially the load power is, that is load power and grid power or inverter power, around 7200 watts, and when battery is providing the energy, it is reduced to 3200 watts. That means when PV is available, it is providing to both load and grid. When PV is not available, to load it is providing the power. And these are the efficiency curves. Initially the efficiency is around 90%, and when battery is providing the power, it is increased to 96 percentage. The reason is when PV is available, the battery is also charging, and the boost converter is also operating. That is, one more converter is operating. When PV is not available, the boost converter stops operating. So the efficiency is increased here because only that inverter is operating. That is dual buck boost AC to DC, sorry, DC to AC inverter. Okay, this is the outputs we can see in this converters. That is when PV is available, what is happening. When PV is not available, what is happening. What is the load power, what is the efficiency, what is the inverter voltage. These are the results.